formation of bonds. The case of helium.
Let us study this phenomenon when we have two helium atoms. We start with the atoms being very far apart from one another. At this point, there is no interaction between them. When they are placed in the vicinity of each other, new forces between the two atoms start interacting. Let us again look at these forces one by one. Forces 1 and 2. We can see that there is an electrostatic attractive force between the nucleus of A and each of the two electrons of B. Forces 3 and 4. Similar to forces 1 and 2, there is an electrostatic attractive force between the nucleus of B and each of the two electrons of A. Forces 5 and 6. We can also see an electrostatic repulsive force between one of the electrons of A and each of the two electrons of B. Force 7 and 8. Similar to forces 5 and 6, there is an electrostatic repulsive force between the second electron of A and each of the two electrons of B. Force 9. Finally, there is the electrostatic repulsive force between the two nuclei of A and B. In the case of helium, we can see that there are a total of 4 attractive forces and 5 repulsive forces. The net electrostatic force of attraction is very slightly greater than the net electrostatic force of repulsion. So, the drop in the potential energy of the system, when the two helium atoms come close to each other, is incredibly small. Very little energy is needed to move them apart, and this energy is easily supplied by the kinetic energy of the gaseous atoms. Therefore, no chemical bond is formed. The two atoms may come close together, but immediately move apart. We depict this on a potential energy diagram, as we did for the hydrogen atoms. Observe that as the atoms come close to each other, the potential energy of the system drops, but the drop is almost zero. The two helium atoms move apart by the slightest of energy supplied, and therefore stay as single atoms. Hence, a bond is never formed.
Starting to feel it? Now go master it with Askmaski.